Machine learning. It's the buzzword you hear everywhere, from killer Netflix recommendations to self driving cars. But what exactly is it? Imagine trying to teach a baby to recognize cats. You show them pictures, saying cat over and over. Eventually, they learn on their own, right? That's basically what ML does, but with algorithms and data instead of babies and pictures. Machine learning is one of the breakthroughs in technology that led to the buzz in artificial intelligence or AI that you experience today. Though AI is a highly spoken and heard term today, machine learning has been with us in our day to day without even knowing. For example, Google search, the personalized content on Netflix and Spotify, weather forecasts, Uber directing drivers to high demand areas, Google Maps showing the quickest routes, chatbots in customer service, facial recognition in smartphones, autonomous cars, language translators, Siri, Alexa, and many others. Now, this wasn't some overnight invention. Back in 1950s, a pioneer named Arthur Samuel defined ML as a field of study that gives computers the ability to learn without being explicitly programmed. What he meant was traditional computing is the use of software programs, where it's programmed with instructions to perform particular tasks. For example, the calculator adds two values when we click the plus sign and gives the answer when we click equal. This might not be easy when it comes to complex scenarios like translating, facial recognition, etc. It may be easy to teach another human, but not when it comes to teaching a computer. Instead of painstakingly programming every step, like teaching a computer every word translation, ML lets computers learn by themselves. It's like giving them a bunch of examples, data, and saying, hey, figure out the pattern here. So, how does this magic work? Data is the fuel of machine learning. Let's take an example. Distinguishing cats from dogs. Picture yourself training a model to tell cats from dogs. You feed it tons of labeled pictures cat, dog. The model analyzes the shapes, colors, and features, searching for clues to tell them apart. Once it's a pro, show it a new picture, even one it's never seen before, and it'll predict if it's a cat or a dog, hopefully. It's like having a superpowered pet detective for pictures. It might not give 100% accurate answers, but there are ways to improve, like tweaking parameters of the model, giving more data, etc. ML isn't just about cute animals though. It can be descriptive, telling us what happened based on data. It can be predictive, forecasting the future, like weather apps. And it can even be prescriptive, suggesting the best actions to take, like helping doctors diagnose diseases. There are different ways to train these brain machines. Supervised ML learns from labeled data, where each example has a corresponding output, like flashcards with answers on the back. The data comes with labels, teaching the model right from wrong. Unsupervised learning discovers hidden patterns in unlabeled data, finding structure and relationships without predefined answers. Think exploring a maze blindfolded. The model finds hidden patterns in unlabeled data, like grouping customers with similar shopping habits. Reinforcement learning learns through trial and error by interacting with an environment and receiving rewards for good actions. Imagine training a dog with treats. The model learns by trying things, getting rewarded for good choices, and avoiding bad ones, like not chasing squirrels. Further technology like natural language processing, machine vision, deep learning, neural networks expanded the ML capabilities. Natural language processing or NLP enabled the machines to understand and process human language, allows ML to analyze text data, translate languages, generate text, answer questions, and even engage in conversation like chatbots. Example Siri, Alexa, understand what you say thanks to NLP. Machine vision or MV enables machines to see and interpret visual information, allows ML to analyze images and videos, recognize objects, track movement, and even generate realistic images. Examples like facial recognition, self-driving cars use MV. Deep learning, a subfield of ML using artificial neural networks, inspired by the brain structure and function, enables complex pattern recognition and learning from vast amounts of data, often surpassing traditional ML methods. Neural networks are mathematical models inspired by the structure and connections of neurons in the brain, serve as the building blocks for deep learning, enabling machines to learn complex relationships from data. Finally, let's move to the pros and cons of ML. Efficiency and automation. ML excels at handling repetitive tasks and large datasets, saving time and resources compared to manual processes. Accuracy and decision making. ML algorithms can analyze vast amounts of data and identify complex patterns, potentially leading to more accurate predictions and data driven decisions. Customization and personalization. ML can personalize experiences by analyzing user data and preferences, leading to improved recommendations, targeted marketing, and tailored content delivery. But ML isn't perfect. Here's what to watch out for. Data bias. If the data used to train the model is biased, its predictions can be unfair. Think of a model trained on pictures of men as doctors. It might struggle recognizing female doctors. Black box mystery. Sometimes even experts can't fully understand how complex models make decisions. This can be a concern in areas like healthcare or law. Job displacement. As ML automates tasks, some jobs might disappear, but don't worry, new opportunities will arise in fields like developing and managing these technologies. Computational costs and resources. Just like you can't run every software or game out there in your computer, training and running complex ML models could also require significant computational resources sometimes. The future of ML is bright. Imagine cars that predict traffic jams and reroute themselves, or robots that perform surgery with superhuman precision. The possibilities are endless. So remember, ML is like giving computers a superpower to learn and adapt. It's a powerful tool, but like any tool, it's important to use it responsibly and ethically. I hope this video sparked your curiosity about ML. Let me know in the comments what you'd like to learn more about. And don't forget to like and subscribe for more tech adventures.